Orion, looks like we don't have audio for some reason from you. From you, I don't know if someone, Sudi, in the comment mentioned, can you hear me, Sudi? Let's see if they can hear me. But for some reason, they can't. Uh, that's odd. Uh, let me go through it. Yeah, I'll go through. Just say welcome to Istio Weekly, and thanks everyone for joining us. Today we'll talk about Envoy fundamentals. I'll talk about basic building blocks of Envoy, and then show you how to create a simple Envoy configuration. Now, after the talk, we'll have dedicated time for Q&A. Audio is okay now. Awesome, thank you. But after the presentation, we'll also like you to be part of this, right? We like to make this a conversation. So if you have any questions or comments, thoughts, ideas, please put them in the chat, and we'll do our best to answer and moderate as it makes sense. Awesome. Looks like for some reason I don't know what's happening with your audio, Orion. Maybe you can write messages and just hold up like. All right, so yay! We do have a couple of more resources for you if you want to dig deeper into Envoy after the talk today. The first talk is called Envoy Deep Dive. It's by Envoy maintainer and Tetrate founding engineer Lejean, and he shares in that talk his thoughts on Envoy design goals, on architecture, and extensibility. We'll put the links to all of these videos in the show notes and in the description below. Also, another video from Matt Klein. Matt Klein is one of the designers and people who actually started working on Envoy, who started Envoy. So this is one of his talk from 2018. He talks about embracing service mesh and actually explains the history of Envoy and the challenges Envoy addresses, or the reasons for why Envoy was built to help these challenges. A 5-minute primer on extending Envoy with WASM is a video by Tetrate's Yaros Kopets. And next week, or actually in the next episode of Istio Weekly, we will talk about WASM a little bit more. And then lastly, Krzysztof Kapulski, he's a Tetrate engineer and Envoy contributor as well. He and Prasad from Tetrate as well talk about Envoy and service mesh for database reliability in the cloud. Now, all of these links for all of these presentations and videos will be available in the show descriptions. So finally, we also want to hear from you. If you're working with Service Mesh, if you're working with Istio, if you're working with Envoy, what are some of the problems you're running into? What are some of the topics perhaps you would like us to cover in these bi-weekly video streams? Leave your thoughts in the comments to the video. We also have a GitHub repo where you can suggest ideas and look at all the resources from the streams, as well as all the demos that we'll go through. All right, so let's start with today's topic, which is Envoy fundamentals. So let me switch to this screen, and let's get started. So Envoy is the engine that keeps Istio running. So the collection of all the Envoy proxy instances in the service mesh, it also referred to as the data plane. So this episode will look at some of the fundamentals of Envoy, some of the building blocks, and I'll try to give you a high-level overview of how the proxy works. So by understanding Envoy, by understanding these building blocks, this will help you better understand how Istio works. So what is Envoy? So if you look at envoyproxy.io, which is the website for Envoy, if you look at that site, it'll say that Envoy is an open source edge and service proxy that was designed for cloud native applications. So the proxy was originally built at Lyft, and it's written in C++, and it was designed for services and applications, as well as a universal data plane for large microservice service mesh architecture, which in this case is Istio. Now, the idea here is you want to run Envoy next to your applications and then have Envoy abstract the network and provide features such like load balancing, resiliency features like timeouts and retries, observability and metrics, and so on. Now, one of the really cool features of Envoy is that you can configure it through the network APIs without restarting. So you don't have to restart the proxy in order to reconfigure it. Now, these APIs are called Discovery Services, or XDS for short, and there's a lot of them. There's a discovery service for pretty much each building block that we will talk about today. Now, in addition to traditional load balancing between different service instances, Istio also allows you to implement things like retries, Envoy, not Istio, retries, circuit breakers, rate limiting, and so on. And also, while you're doing all that, while you're using all those features, doing the load balancing, capturing the requests and all, Envoy also collects rich metrics about the traffic it passes through it. And then it exposes these metrics for consumption and use in tools such as Grafana, for example. Now you can imagine Envoy being a data plane in Istio where it's intercepting all the traffic that's entering your service, it's intercepting all traffic that's exiting your service, and it's doing that for every service instance. And it collects all the data about and all the metrics about those requests that are flowing through the proxy to your services. Okay, so let's talk about the building blocks of Envoy. So let's say we have a proxy running, and the proxy is sending the request through a couple of services. So what we're trying to do is we're trying to send a request to the proxy so it will end up on one of the backend services. Now, in order to send a request, what you need is an IP address, and you need a proxy, you need an IP address and a port that Envoy needs to listen for, right? So this address and the port that Envoy proxy listens on is called a listener. And there can be more than one listener. So Envoy can listen on more than one IP and port combination. So this is a way that Envoy can pretty much receive connections or requests. Now, attached to these listeners are routes. And routes are a set of rules that map virtual hosts to clusters. So this is where you can look at the request metadata. In routes, you can look at, let's say, headers or URI paths, and then route the traffic, the requests, to clusters based on that. And I'll explain what clusters are in like 30 seconds. So for example, you could say in routes that if the host header on the request is set to hello.com, then I want to route the traffic to service A. Or if the next route or the next matching rule could be, check if the path starts with /API, and if it does, I want to route everything to a service called an API service. So based on this match that's being done in the route that Envoy does, Envoy will select a cluster. So a cluster is just a group of similar upstream hosts that accept traffic. So for example, if you continue the previous /API path matching that we had, we could have a cluster, for example, that represents our API backend services, or a cluster, for example, that represents a specific version of either front-end services or backend services, and so on. So all of this is configurable, and you can decide which hosts are included in which clusters. So clusters are also the place where we can configure things such as outlier detection, circuit breakers, connection timeouts, and different load balancing policies. So once we've received the request, we know where to route it using the routes. We know how to send it using the cluster and the load balancing policies. We can then select an endpoint to send the traffic to. So this is where we go from a logical entity of a cluster A or whatever the name is to an actual physical IP address and a port in an endpoint. So you can also structure your endpoints in such a way that certain instances can be prioritized over other instances based on the metadata. For example, one thing you could do here is you could set up the locality of endpoints to keep the traffic local, to send it to the closest endpoint depending on the incoming traffic. So let's look at this same thing that I've explained in a little bit of a different diagram or picture. So this is how we've defined the listeners, route matches, clusters, and endpoints. So we have two listeners in this case. One is listening on port 9090, and the second one is listening on port 80. Each one of those listeners has a set of domains and routes and route matches. So let's say a request comes in with the host set to api.tetre.io, and it comes in on a port 9090 with a path /v1. So the request will be accepted because Envoy is listening on that port combination. It will get accepted by that listener. And then from there, it will go through a set of filters, and I'll talk about filters next. And a route will get selected based on the host header, which in our case is api.tetre.io. Based on that, as well as based on the route match, which is /v1. So this is how a route will be selected. Based on that route selection, in the route, we also define a cluster that matches that route and domain combination, and we select a cluster called an API cluster that has a set of, in this case, 3 endpoints, and then requests that came in will be sent based on the load balancing policies and rules defined in the API cluster to one of those 3 endpoints. Similarly, if we would send a request to a listener on port 80, the request would be matched following a similar process. So it would look at the domain first, and then it will look at any route matches and try to match the domain with the route, and then route it to a specific cluster. And then from cluster, it will go through a specific endpoint. So I've mentioned how the request will hit one of the listeners, and then it will go through a set of filters. So there are 3 types of filters that Envoy currently provides, and they form a hierarchical filter chain. So the first type of filters are called listener filters. So these filters are attached to listeners, as the name suggests, and they can access raw data and can manipulate metadata of L4 connections during the initial connection phase. Just an example, there's a listener filter called TLS inspector filter that can identify if the connection is TLS encrypted and then extract relevant TLS information from that connection. And when I say extracted, it means that it can be used later on to either select a different filter chain or do some processing based on that. The second type of filters are network filters, and these work on raw data as well. They work on the TCP packages. An example here is a TCP proxy filter that routes client connection data to upstream hosts and then generates connection statistics. The last type are HTTP filters, and these operate at L7 with HTTP data. So these filters are optionally created by the last network filter in the chain. So the last network filter in the chain is the HCM filter, or HTTP Connection Manager filter. That filter, the HCM filter, translates from raw data from L4 to HTTP data, and then these HTTP filters can then manipulate HTTP requests and responses. Here's another view. So listeners have a set of TCP filters that interact with the TCP data. There can be more than one TCP filter in the chain. The last one in the chain of network filters is a special one, and it's called HTTP Connection Manager. And that's the filter that actually turns Envoy into an L7 proxy, right? So it converts the bytes from the request into an HTTP request. Now, within the HCM filter, there's another array of HTTP filters that work with HTTP requests. So this is where you can do things on HTTP level. So you can work with headers, you can interact with the HTTP body, and so on. Within this HTTP filter is also where you define your routes and the cluster selection. Now, the last filter in the chain is called a router filter, and this is the filter that will actually send the request to the selected cluster. So what are HTTP filters? You can think of them as code that can interact with requests and responses. There are a set of HTTP filters that ship with Envoy and are built into it, but you can also write your own filters and then have Envoy dynamically load them. So this is something that we'll talk about in 2 weeks in the next episode, where we'll talk about WASM. So these HTTP filters are chained together. So if you're deploying your own custom filter or configuring any of the existing HTTP filters, you can actually control the order or where in the chain you want to place the filter. Now, the fact that these filters are chained, so there can be more than one and then go from one, first one, second one, third one, and so on. So each one of those filters needs to make a decision to either continue executing, right? Move on to the next filter, or just stop executing, close the connection, or just don't continue the chain anymore. Don't send the request, pretty much. So there's no need for you to have the filters built in or compiled with the Envoy proxy. You can do that if you want to, but it's not practical. And WASM is one of the things that allows you to. So Envoy filters are natively written in C++, right? But what WebAssembly and WASM allows you to do is to actually write filters in Go or Rust. And I'll show you how to do that in Go next time. Also, there's a filter called the Lua script filter that allows you to write Lua script code and then include that code as an HTTP filter in the chain. So just a little bit on dynamic configuration. I mentioned this. So in the demo, I'll show you how to create static configuration. So we'll create a YAML file where we will hard code all the listeners, all the routes, all the clusters, and all endpoints in a single config file. And then we'll just start Envoy with that configuration, right? Now, a big feature, or like a really, really cool feature of Envoy, is the ability to use dynamic configuration. So instead of hard coding your endpoints, your IP addresses, what you could do is you could write a service that provides the information about those endpoints, about the routes, about the clusters, provides the information dynamically. So you can create your own service either as a REST endpoints or gRPC streaming endpoints, and then return the configuration dynamically, right? In the Envoy configuration itself, instead of providing those IP addresses and hard coding the endpoints or clusters or routes or whatever. So instead of doing that, what you do is you can just point to this third-party service that you've written and say, hey, Envoy, go there. Like when you need the endpoints, go there, and you'll get the endpoints back, right? And you can control the refresh interval and all that. So what this effectively allows you to do is it allows you to create your own control plane and integrate that control plane with Envoy. And if you've done any work with Istio, this should sound familiar because this is what Istio does, right? So Istio's pilot component, this covers all the services that are running in Kubernetes in this case. So it reads the Kubernetes services, it reads the service endpoints in Kubernetes, it gets all the IP addresses, it gets all the ports, and then it converts that data, the raw data from the Kubernetes, converts it into configuration that's readable to Envoy. And since Envoy is configured to talk to the pilot to get its configuration, pilot sends that Envoy configuration back to the proxies, to the data plane, through these different discovery services. Are there any questions so far? All right, I am looking at the chat just to see if any questions pop up. But it's time for the quick demo. So in this demo, what I'll do is I will run two simple Node.js applications in Docker containers, right? And these two apps, the blue app and the green app, will be exposed on two different ports. Then I'll create the Envoy configuration that will route all the requests that are sent to /blue path. It will route everything to the blue application, and anything sent to /green, it will route it to the green application. Now the Envoy proxy that I'll have will be listening on port 10,000. And just for the simplicity's sake, both the demo applications as well as the proxy will be running on the same machine. All right, so let me switch to the demo now. And we'll go through this in a second, just so I prepare everything that I need. All right. Okay, so we're still streaming, we're still live, so it's all good. Okay, so I'll start by running those two Docker containers. The first one will be blue. So let's just run this one. This is just like a generic app that I've created that just changes the background on the website, right? It's an Express application. Serves just a simple website that with the background that you specify in from the environment variable. So I'll run this on port 5050. So let's do this one. Let me authorize this. Looks like I'm not connected, so let's reconnect. So this will be the blue application, and then we'll also run the green application, which is the exact same Docker image. The only difference is that the blue will be listening on port 5000. So let's do that. Okay, so let's do Docker PS just to see that both of these are running. That's great. And then let me just show you. We'll do preview on port 5050. So this is the blue application, and then if we do 5000, this is the green application. This is all that these applications do. All right, so let's do that. So next thing that I'll do is I will install a CLI that's called Funky, and this is the CLI that you can use to work with Envoy. So it just allows me to, it just automatically downloads Envoy for me, and it allows me to run Envoy. So let me download this. Okay, and let's do a folder here. Oh, looks like I've already created that folder. Perfect, so it's empty. So funky, let me run this. So this is just a CLI that allows you to install and run Envoy. So question on capturing the metrics from Envoy and viewing them, we need something like Kiali, especially. I mean, Kiali is just taking the raw data, right? You could, like, Envoy exposes these metrics in a Prometheus format as well. So you can take that data, you can use Grafana, you can use whatever your observability tool is to get those metrics in and then visualize them with graphs and dashboards and whatnot. All right, so let's create a file here. I'll just call it config.yaml, and I'll make this bigger here. Perfect. Okay. So I'll start with a very minimal configuration that doesn't do much, pretty much doesn't do anything, right? So I'll just paste it in here and I'll explain what it is. So as I said, we'll be using static configuration. So it all goes under static resources, and we're defining a listener. We'll only have one listener, just call it listener_0. You can call it whatever you want. And then under the address and the socket address field, we're setting the address to 000 and a port to 10,000. Then, because each listener has to have a filter chain, in our case it's empty, we have to specify this in order to make it a valid configuration, right? Valid, but not very useful. So let's run this. So I'll do funky run -c config. That's all I need to do. And I already have the latest version downloaded. And what this does, it just starts Envoy, a lot of logs here. So main dispatch loop has started, Envoy is running, and it's listening on port 10,000. So let's see what happens if I do curl localhost 10,000. I'll just do verbose closed, right? So the connection will be closed because there's no, like, we're not telling Envoy what to do, right? There's no filter chains, there's nothing, it doesn't know what to do, it'll just close the connection. So let's make this a little bit more useful. And the next thing that we'll do is we'll update the filter chain by adding that. So let me paste it in here and I'll talk through it. By the way, is font size okay, or should I make it a little bit bigger? I guess I can probably hide this one, right? Let me know if the font size is okay in the editor. So under the filter chains, we are defining an array of filters. We'll only have a single filter. Note that these are network filters, right? We have a single filter and we have this special filter called HTTP connection manager, right? So this is the name, the config, stat prefix. So we'll talk about stat prefix later on, but this is just for all that rich metrics and statistics that's being collected. And then this special network filter can have a set of HTTP filters. In our case, we have the single filter, and if you remember, this is the router filter. This is the last filter in the chain that has to be the last one that actually does the routing. And then under here, we have route config that's empty, meaning we're not actually saying how to route the traffic that's incoming. So let's rerun this. So I'll do funky run. Main dispatch loop has started, and I'm just switching windows here. Let me clear screen, and we'll try to send a request again, and we'll just do -v. Now notice this time there is a difference. The connection was not closed, right? Because we had the filters, the request went through the HCM filter, it went through the router, but there was no route config, so Envoy didn't know where to route the request, and therefore it just returned a 404. And you'll notice that it went through it because Envoy set the server Envoy header on the response headers, right? So it went through the proxy, didn't find any routes, and just returned a 404. So let's make this a little bit more useful and just create a very simple route or route config, they'll just return a direct response, right? It's not going to route to anything yet. So let me paste this in. So under the route config, we added this virtual host. We're just calling it direct response service. Again, you can call it whatever you want. We're setting the domains array to star. Like if you remember from the slides, I had the api.tetrate.io or hello.com or whatever it was. Over here, we're just saying we don't care what the host header authority headers are set to, just match it for all of them, right? So as soon as this matches, there's a route, and under routes, we have this match defined that is saying just match on the prefix, right? Just match on this one. If these two conditions are evaluated to true, which they do, just send a direct response. Just send 200 with a body called hello. That's it. Let's just do that. So let's run this. Start it. I'll switch to our test tab, and let's send a request here. Notice that this time we got back 200, and then down here you'll see that says hello, which is just the inline string that we define, right? Now sending a direct response like this is not it's not really useful. It's just for testing. So let's do something more useful, and actually, instead of sending a direct response, let's create a route config that will select a cluster. So let me replace this with this configuration. So this portion is the same. We're just matching on all domains. We don't care if you're from hello.com or example.org, it doesn't matter. And then we're also matching the prefix. So we're saying if you come in on any domain with the prefix /blue, let's route to cluster called blue. And then if you come in on /green, let's route to a cluster called green. Now, in order for this to work, we also need to define the two clusters. So let me paste that in, and this is more verbose here. So we're defining the clusters under the clusters field. Each cluster has a name, and under there's a plethora of settings and configurations that you can set. We're setting the connection timeout to 5 seconds, creating a load assignment, naming the cluster here, and then specifying the endpoints, right? Load balancing endpoints, and then the actual physical IP address and port. And we're running our blue on, just double check, it is 50/50. Just make sure, blue 50/50. And then same thing down here, right? But this one is green, and we're running it on port 5000. Now imagine, like this is like extremely simple example, but in real world, you're probably not gonna have only 2 endpoints, right? So as I was talking about the dynamic configuration, instead of doing this, what you would effectively do is you would say, I'm making this up, this is not the real syntax, right? Actually under endpoints, right? For endpoints, go and look at this XDS service, right? And this XDS service would be a separate cluster again, with an actual IP address and a port where Envoy can go and ask for the configuration for its endpoints. All right, so let's see how this works. So let me reconnect here, and if any dedicated course you're designing around Envoy, maybe. Is this something that you'll be interested in? Might be something I would love to work on it, to be honest. Envoy is extremely it's so configurable. It's crazy as you start looking into it and just digging into all the it's nuts how many buttons and settings and things that you can change and configure. It would definitely be interesting to dig into. So yeah, leave a comment if that's what you'd like. If someone else would like us to do a course or something, that would be great. All right, so this is started. So remember, we defined the prefixes, we defined the clusters. So let's see how this works. So I'll do actually, I don't have to do it that way, right? I can go to port 10,000 here. So let's see if this works. So this shouldn't return anything. That's fine. But now if I go to /blue, there we go. So this is port 10,000. I'm going to /blue, and the request is going through the Envoy proxy, and it's routing it to the blue container that we have running. And then instead of blue, if I do green, I'll get the green back, right? And let me just do it here as well. So localhost 10,000. Let's do blue. And you'll notice here background blue. And if we do green, you'll notice here that it's background green. All right, so let's do one more thing. What I want to do is I want to show you how to enable the metrics. So you'll see down here where we have the proxy running. There's no like access logging. There's nothing here, right? Let's see how we can enable, right? How we can enable metrics and then enable the access logging. And I'll start with the access logger first. And we'll define the logger, the access log, under the HTTP filter. So let me copy paste and I'll explain what it is. So this is the thing that I've pasted, these 4 lines. So it's an access log field. The name of the access logger is standard out, which means it will just it'll just log everything to the standard out. There's other options here for logging. You can, of course, log to a file, or you can also provide an access log service, right? So again, you could have like an external thing, your own third party, whatever service for logging that you want to use, and then Envoy can connect to that, right? Envoy can connect to that and then send you the logs to your system, right? You don't have to log to files or standard out, right? It can be to your proprietary system if you wish. All right, so let's close this. So let's rerun it again. Same thing here, but then let's go back and just refresh. Let's refresh green a couple of times, and then let's do blue twice or 3 times. Now you'll notice that this time we actually get the access logs, right? There's a GET request to green. The connection was 1.1. I think this is like a request length or time or something like that. What was the browser we use in this case? Request ID. The request came into the port 10,000, and this was the actual address of the service, right? So you see 5,000, port 5,000, and then down here when we were requesting blue, you could see port 5050, right? So we've done this, we've done the logs. How about the metrics, right? So the way that you could, so Envoy exposes a statistics or stats endpoint, but in order to get that enabled, you need to enable a so-called administrative interface. So let me paste that in. There you go. This is how you configure it. Now, this is unprotected, right? This is not how you would do it in production, of course. Like, nothing that I've shown today is what you do in production like this, but just a caveat here, you don't want to expose this. Like, you don't want people to have access to this, right? So another question, in case if mesh is mutual TLS enabled, Envoy filters are used to intercept the MTLS certificate and verified with the certificate authority. So the way that mutual TLS, yes, Envoy can do that. Envoy can make sure that the certificates are valid and all that. But one interesting thing, since you brought it up, one interesting thing that around MTLS is the permissive mode. And I think we talked about permissive mode in the last video on security. So permissive mode is where your service or your Envoy proxy can either receive plain text or it can receive TLS connection. It doesn't matter, right? And the way that that's done, and that was really interesting, is with the filters, right? So in the filters, what you can do is you can define something called a filter match, right? So you can do a match and say, based on you can inspect the connection and say, is this a TLS connection? If it is, then go through this TLS chain. If it's plain text, then go and pick this other filter chain. So it's really interesting. Once you dig into the actual configuration, I know we've talked about it from the Istio's perspective, which is like from a higher level. If you look at it at a higher level, it's just a setting, right? You set it in the peer authentication. You set it either to like permissive, right, or strict, or whatever you want to do. But then that actually translates to Envoy configuration, and the way that it's done, it's by filter matching, right? So there's a separate set of filters. If the connection is strict, for example, there'll be just one, right? There's not going to be a plain text one, right? It'll just generate one. But if it's mutual, if it's permissive, right, it's going to be both. All right, so let's do the admin. So we have it enabled. Let me just rerun it again. And you'll notice that down there it says discovered admin address. Let's send a couple of requests to blue, and let's send a couple of requests to green. Let's refresh, and now let's actually open this. Actually, no. Let's look at the stats endpoint first. So I'll just curl to localhost 10,000, and then we said 9901. 1/metrics, stats. It's, of course, it's not 10,901, it's just 9901. Stats, and you'll notice you get back, if I scroll higher up, there's a lot of metrics that are being connected here. And notice this HTTP edge thing. So this edge name, this is what we called, this is the stat prefix that we set in our HTTP connection manager. So if you look at that, this is what you get. And this is the listener, right? For example, this is all separated by the listener. It shows you the number of downstream requests, the completed requests based on the response, total downstream requests, right? There's a lot of stuff here. And this is just the /stats endpoint. There's also a /stats Prometheus. If you want to get a Prometheus style metrics out of it. And this is something that you can feed into Grafana, right? Grafana knows how to like read and parse this. You can use that query language to parse these values and parse these numbers out. So let's look for, let's just grab for green, for example, right? So these are all, I'll actually do the non-Prometheus ones, right? There you go. Right, so it shows you the requests, right? What was the response there? If it was healthy, any zones, like load balancing zones, if we would have defined, any circuit breakers, right? Any errors. Basically a rich set of metrics. Without us, like I didn't do anything, right? This is all, this was all Envoy automatically collecting these metrics. Also, let me just open that admin interface. Oh, that doesn't look right. Let's try it here. So change port 9901, change in preview. All right. So this is the Envoy admin interface. This is what got enabled by those last 3-4 lines that we added. And this is where you can actually look at like the upstream cluster status, right? These are all the things that we've seen in the metrics as well. You can look at the configuration, right? All the configuration settings, listeners, right? Memory, you can change the logging levels. Basically, administrative interface for Envoy. All right, so this was for the demo. Let me quickly switch back to slides. I think Orion had like a slide or two, right? That was just one slide. Yeah, so I hope you all liked this and it was useful. So you can find our schedule for the Istio Weekly. Like, we do it every 2 weeks. You can find all the information about that, all the information about like the resources and everything that was used, the demo even. I'll post the demo flow. You can go to istiotetradalabs.io, or you could go to GitHub. So it's under tetradelabs/istioweekly, or just go to istioweekly.com. We have all the links there. If you want to chat with us, if you have questions, join the Istio Slack. We are on the Get Istio channel. And yeah, and that's all from us. I apologize for the audio issues that we had, and I'm pretty sure we'll fix this for for the next time. And we're looking forward to see you in 2 weeks, and we'll talk about WASM specifically. Thank you very much.